their focus is specifically angles and angle measures. And when we are drawing our angles, they are always going to be in what we call standard position. Okay, and the standard position is when the vertex is at the origin, and one of the rays that makes the angle is on the positive x-axis. Because there are two sides to the x-axis. There's the positive number side and the negative number side. Okay, and then we have what is called the initial side. And that is the ray that is on the x-axis of an angle. And then the terminal side is not on the x-axis. And really, it's going to be anywhere. They just say generally that it's not on the x-axis. Okay, so the terminal side, the ray is not on the x-axis. So we're going to draw these so you get a better understanding of what those definitions mean. Okay, so you have two rotations. You can have a positive rotation or you can have a negative rotation. Okay, a positive rotation is counterclockwise. A negative rotation is clockwise. So for your initial side, it is always on the positive x-axis. So go ahead and draw your initial side in. We are going to label it in our diagram. And the initial is where you start. So you are always starting on the positive x-axis. The reason why you're always starting there is because it is equivalent to 0 degrees. And then we're just going to draw in the terminal side together. It does not, yours does not have to be in the exact same place that mine is. So it'll be a ray, and then I will actually going to give you guys some straight edges today. Okay, and then this is the terminal side. Okay, so back in the good old days when you were in geometry and you were looking at angles, right? You might just have had an angle that looked like this. Now we're putting those angles on the grid. Okay, and then we have a special symbol that we use for angles, and it is theta. Okay, so this is theta. Theta represents the degrees. Okay, and today we're going to be doing everything in degrees, so I do want you to make sure you're putting in your degree symbols. Yep, the theta, it is. It's like a 0 with a line through it. Okay, so if this is 0 degrees, you guys may remember this is a right angle, so it's a 90 degrees. And then a straight angle is how many? 180. And then see if you can write what this is in degrees and what that is. It's okay if you don't know, I just want you to think about it. So if it goes 90, 180, I just want you to think about what the next one is. If you're feeling confident in what that is, feel free to write it down. If all you can do right now is think about it, that's fine too. All right, Cody, can you tell me what that one is? Yes, the negative part of the y-axis. Yes. Okay, and how did you find it? So we're going to be working with quadrants, and you guys talked about quadrants in Algebra 1. Do you guys remember what quadrant 1 is? Yep, the top right. And the reason why that is the first one is because that is where the X and Y's are both positive. Okay, we're going to write the quadrants in here. Now each quadrant is 90 degrees. Okay, so you have quadrant 1, and we usually use the Roman numerals for the quadrants. Then 2, it goes around counterclockwise. This would be 4. So if each quadrant is 90 degrees, all you have to do is 180 plus 90 to get 270. And you guys probably know one full time around is how much? 360. Yeah? Great. Okay, now for the negative rotation, that is going to be very similar. In fact, we're going to keep the initial side and the terminal side at the same place. So I can show you the difference between those. Okay, now before, theta started at 0 and went counterclockwise. Now we're going to start at 0 and go clockwise. So your theta is still in degrees, but this would have a negative value. So when you're labeling these, it is very similar. You have 0, now you have negative 90, negative 180, negative 270, all the way up to negative 360. Okay, but you still have the initial side, and you still have the terminal side in the same position. No, the 0 won't be positive 1. That will always just stay.
Wait, so the terminal and the initial just switch the side?
Nope, so they're in the same place. Okay, so in this case, the only thing that changed was our rotation. So if you're rotating positive, you're going counterclockwise, and if you're rotating negative, you're going clockwise. So let's summarize. That's what we're going to do here. So the angle of rotation, you rotate the terminal side. Okay, so the terminal side moves, but the initial side, that's going to stay in place. So you're going to keep the initial side in place. Okay? When you are rotating counterclockwise, which is what we did in this first one, that is when you have a positive angle. Okay, and when you rotate clockwise, that is when you have a negative angle. And we're going to practice doing those together. Okay, when you are rotating angles, you can rotate angles to more than 360 degrees. Okay, it wraps around, it makes a spiral. So we are going to graph one of those together. Okay, so the first thing I want you to do is I want you to draw the initial side and the terminal side. Okay, so here's the initial side. We'll keep this terminal side in, let's keep it in quadrant 2, but doesn't have to be the exact same as the one before. Okay, and then when you are doing the rotation, okay, we are going to start at 0, and then we're just going to go more than 360. So why don't you guys watch me first, and then I'll let you do it. Okay, so we're going to start at 0. We're going to go one full rotation. It spirals around and goes to your terminal side. Okay, so we're going to start here, and then we're going to go around. Okay, so for part A, I'm going to have you guys try this, and then we're going to start with that initial side. Okay, I'm going to bring around protractors. Now, these do not have to be exact, but it does need to be a reasonable estimate. Okay? No. It's right on it, so it's the line. Both the thing is the line. Yes. Okay, so I have a couple different types of protractor. Alright, put your terminal side where that's going to go. Okay, so I want you to start thinking about that. So some of you don't have your initial side yet, and I already have mine up there. So you should have yours up there too. Okay? So go ahead and put your initial side on there. And then you are going to 320 degrees. So think about where that is. I knew it was a school. Okay. So with the 320, this is what I want you to think about. Okay. So when you are trying to find 320, if you're not sure, then the first thing I would do is start labeling. So we know that this is 90 degrees, 180, 270, 360. So if it's 320, what quadrant is it in? It's in quadrant 4, and I said you can estimate. So if this quadrant is 90 degrees, then I know that half of the quadrant is what? 45. So if you just want to cut it in half and then adjust it, that's fine. If you want a more precise angle, there's a few ways you can do it. If you have this safety angle, you can just measure 40 degrees, and then the center goes here, and then you can put this right on the line. For this one, I usually have to use my pencil first to get the point where I want it to go. So if it's 320, we know it's 40 degrees away from 360, right? So when we go from here to here, my theta, which you're going to have to write, theta equals 320. What I have in blue here, that is required. Okay, so you have to have the initial side, the terminal side, this angle, and then theta is equal to 320. I'm just going to say that one more time. When you are doing your homework, everything that I have in blue up there, you have to have. What is optional is labeling like I did here. What else is optional is you might want to write that this is 40, right? Because 320 to 360, 40 degrees. Alright, so I want you to go ahead and I want you to graph in negative 110. So negative, you have to go counterclockwise. So start thinking about that. Alright, so one way you could have thought of this is that is 20 degrees past negative 90. So sometimes it's easier to think of it in that way when you are graphing it. So if it's negative, I'm going to put on here that this is negative 90 to help you. Right? And then you're going to be estimating. And then I'm going to show you this time with a smaller protractor. If you have one of these protractors, when you do your test, I'll put the protractor on there and I'll just make sure it's reasonable. So this should be 40 degrees. Can you guys see I'm pretty close there? Okay, and then for this one, you could just use that upside down T, and then it should be about 10 degrees. So if this is 90, okay, or sorry, not 10, 20 degrees. So this would be 90, and then 10, 20. So I'll put it about here. And again, just a reasonable estimate is fine. Okay, so then initial side is here. This is where your terminal side should be. And then you have to use the arrow to show what direction. So it starts at the initial side. Okay, so theta is equal to negative 110. Okay, and all you need to have on there is what I have in blue. Okay, but if you want to write those on there, you can. Okay, did some of you start on part C already? Okay, so it's 990, so it's definitely greater than 360. So if one time around is 360, what's 2 times around? 720, because you just double it, right? Okay, so what's 720 plus 180? 900. Okay, you could also just do plus 90. So it would be 810 plus 90. What's 900 plus 90? 90. Okay, so that means your terminal side for this one is right on that line. So your initial side always the same. Terminal side is dependent on what your angle is. Now when you do this, you're going to watch me first and then do it you can. Remember, you have 2 rotations. So as I'm doing this, because it's positive and going counterclockwise, I'm thinking to myself, okay, 1 time around, 360. 2 times, 720. Okay, so it will hit the edge.
Doesn't the line have to be in highlight?
No, but it should be visible, so.
Okay, got it. Appreciate it.
Okay, and then once you have this, you are going to write your theta. So your theta value is equal to 90. Okay, and I gave you grids for this. If you guys want to do yours on graph paper, you can. You can also draw these yourself on line paper, that's fine. Okay? Alright, so a lot of the things we're dealing with are going to have some special notations, some special vocab words, and one of those is co-terminal angles. So think of that prefix co, right? If I'm co-workers with somebody, what is that? Together, right? We work together. So co means something's going to happen together, okay? And then it's terminal. So angles in the standard position are going to have the same terminal side. You can think, oh, if we're co-workers, we work at the same place. If they're co-terminal, they end at the same place. They have the same terminal side. Okay? Now, there are an infinite amount of co-terminal angles. I'm going to think about why that is, and we'll answer it in a moment. going to be an infinite amount? And before we answer that, we're going to draw an example here. Okay, and then we'll just pick somewhere in quadrant 1. So draw your terminal side somewhere in quadrant 1. Doesn't matter to me where. Okay, so if you have an angle, we're going to call this theta sub 1. That is one possible angle that has this initial side and this terminal side as pictured. However, that is not the only angle that you can have. You can also have the angle that starts at the same initial side, but it goes clockwise. We're going to call that theta sub 2. Those are coterminal angles. They start and they end at the same place. They're just going in different directions. Okay, can you guys think about how we could draw another one? Yeah, you can keep rotating, right? So that's why we have an infinite amount, because you can rotate an infinite number of times. Okay, so you can rotate an angle. And this is my symbol for angle. I do an angle with a little. You want to do it? You can rotate an angle, an infinite number. Okay, so I started here and then did a full rotation. Okay, that could be theta sub 3. Okay, and I could just keep continuing with that forever. Okay? Alright, so in order to find coterminal angles, I'm going to tell you what the equation is, but I want us to investigate that first before we write it down. So we're going to do example 2 part A, and then we're going to come back and fill this in. So when you're finding coterminal angles, in this case, we're going to find the measure of a positive angle and a negative angle that are both coterminal. Okay? So I want you to understand where our formula is coming from. And for A, you're going to be given that theta is 65 degrees. So let's go ahead and draw that. Okay, I want you guys just to estimate where that value of theta is. Okay, so you are graphing the 65 degrees. And then once you have graphed that, why don't you try to find the one that's coterminal based on what we did above? Okay, so you're at 65 degrees. Okay, how far away are you from 90? 25. Okay, so theta equals 65 degrees. Can you guys draw in the other angle even if you don't know what it is yet? Can you guys draw in one of the coterminal angles? Yeah, it's just the angle that's what? Just the angle that's clockwise, right? So it starts here. How can I find what that angle measure is? What do you guys think? Yeah, you can subtract it from 360, okay? And then it has to be negative, okay? So we can do 65 365 minus 360, we're going to be doing these by hand, which is really going to help you understand how those angles work, and it's going to make some of the things we're doing in the future a little bit easier. Okay, so if you're subtracting that, this is how I set it up. I know my answer is going to be negative, but if I do 360 minus 65, okay, in your head, it's going to be easier for you to do 360 minus 60, which is 300, and then 300 minus 5, 295. Okay, this is going to help your brain start thinking about the 90-degree increments, okay, which you really haven't worked with in a while. Okay, and then the way to find the other one is having a what? It's a positive, and how do I find it? So how do I find the other one? So I have theta 1. We found theta 2. What's theta 3?
How do you find the second one?
You subtract it from 360. So you're going to go the other way.
Subtract 360 from it.
Yeah. Yep. Okay, and then, so how are you going to find theta 3? What are you going to do? Yeah, you're going to add 360 because it's a full rotation, right? So you do one full rotation here. So all you have to do to find that other theta is 65 plus 360. I didn't line those up well. Okay, but this would be 5, 12, 31. Okay, so going back to our directions, we needed a positive angle, we found one now, and a negative angle. So in the first one, we subtracted 360 from the angle. Okay, for this one, we added 360 to the angle. So to find the coterminal angles, all we have to do is add or subtract 360 degrees. Okay, and you guys found that. Okay, now you can also add or subtract multiples, but honestly, you're not usually going to do that. Usually what you're going to do is add 360 twice or subtract 360 twice. You aren't going to use the multiples, but you could. So you could do 360 times 2, and if you added or subtracted 720, that would also give you some coterminal angles. You could do 360 times 3. Okay, you could add or subtract those, you will get coterminal angles, because that's just twice around. That's just 3 times around. Okay? Alright, so I want you to try B, and you don't have to draw the picture. So I think the picture is helpful when we're figuring out like why this works. Okay? I'll keep that up there. So you can just use your equation now. Add 360, subtract 360. Alright, so this one should have gone pretty quickly, right? You don't have to subtract first. You could also add first. It doesn't matter. If you added 360 first, then you got 770. Now, please make sure that you are using your degree symbols. I am. I want you to. So the 770 degrees, that is positive. Now, if you subtracted 360, Okay, 410 minus 360 is what? Yep. Now this is also positive, so we're not done. So there's more than one answer you can have for positive, okay? And then if that happens, what should we do now to find the negative? Minus 360 again. Okay, and when you are minusing 360, okay, it's a lot easier for your brain to do 360 minus 50. What's that? Yep, so this is just negative 310. Okay, and again, plug your degree symbol. Why? Because tomorrow we're going to measure in something that's not degrees. Okay, so we'll need to. So it's just different. Okay, and then this one's negative 360. Okay, so I want you to do one positive, one negative. One positive, one negative.
Is zero? Zero? So I have to ask. Is zero positive?
What is it?
It's I think it's what was the word extravagant? Extraneous. Stella, I love extraneous. Yeah. I can or 360 minus 360 minus 360.
So if you add 360, you get 0. Is 0 positive or negative?
Zero.
Neither. Okay, so that's not going to count. So then what do? Add 360 again. Okay, so if I add 360, then I get 360. Okay? Or if you knew that was negative and you wanted to add 360 again, you could. 720 would be another possible answer. So if you add 360, you get 0. Okay, that's neither, so I add it again. Okay, do you have to show your work for this? No, I'm just doing it for your notes so you can see the process. Okay, and then the next thing you would do is just subtract 360, which is just doubling it, right? So negative 700. Okay, so the last thing we're going to talk about today are reference angles. And again, I just want to reiterate, a lot of the stuff we're doing is going to tie together. Okay, so it's going to be important that we understand these. So when we are working with the reference angles, they are positive, okay, and they are acute, or they are right angles. So it technically says the positive acute angle, but it could be right in some cases. Okay, so it's the acute or right angle that is formed by the terminal side of theta. What does acute mean? Yes, okay, less than 90. So it's either less than 90 or equal to 90. It's either less than 90 or it is equal to 90. Okay, and it's formed by the terminal side of theta and, I'm going to put this in another color so it stands out, and the x-axis. Okay, so it has to be to the x-axis and not to the y. And the x-axis has two sides to it. It's going to be the shortest distance. So we'll go over that. It's honestly easier to grasp when you see a picture, so give yourself some time to process. Okay, wait till I go over the table with you, okay? So, I just want to be sure that you know it is always positive. Okay, it is never not going to be positive, or always positive. And then we're going to do an example together right here, and then I'm going to let you give it a go. Okay, so for your example, we So theta equals 135 degrees. So I'm always starting with my initial side. The initial side is always here at 0 degrees. Now, I've been thinking to myself, where is 135, right? It's been a while since geometry. Think about what is the distance between 90 and 135. How many degrees past 90 is 135? 45. So that's going to be halfway. So again, we can just cut this in half. Okay, you can measure with your protractor, or at the halfway, just kind of, we're doing it on a grid, it's pretty simple to estimate. Okay, so theta is 135 degrees. When you are determining what your reference angle is, it's the shortest distance to x. So you have two options. You can either go from the terminal side to the positive x-axis, or you can go from the terminal side to the negative x-axis. Which line is shorter, the red or the blue? The red. Okay, so if you're watching the video, you can't see this because it was on the smartphone. Okay, so the shortest distance is going to be to the negative side of the x-axis. This is your reference angle. Okay, so that is your reference angle. And that is equal to how many degrees? Yes. Because the distance from 135 to 180, right, is 45. 45 cuts it in half. Okay, so this here would be greater than 90, and so we can't use that. It's always to the x-axis, okay? So when you are doing these that are similar to example 3, where you have to find the measure of the reference angle, anytime you have to find the reference angle, I want you to draw the angle. And then I'm going to let you guys do these two. So theta is 325, for A, and then for B it's negative 105. Okay, so I want you to start by drawing the angle, please. And even if you're unsure what your reference angle is, at least mark it off in your picture. turned out, if you have 325, where is the terminal side? In which quadrant? Okay, quadrant 4, great. Okay, so this is your initial side. Okay, and then as you are creating the angle, you should be thinking to yourself, all right, if this is 270 and this is 360, what's the distance between 325 and 360? 35. So are you guys thinking about that when you're making your angle? Or no? You aren't? Then how are you spacing this? I'm curious, sorry, I don't mean to interrupt. I'm curious. Are you guys thinking about how much past 270 it is? Okay, so did you really just tell me? Did you really just tell me that? Okay, so if you're thinking about how far away is it from 270 to 325, what is that distance? When you guys made it. So 270 to 325. Okay, so if that's your, isn't it 55? Okay. So either way, you're either thinking about, hey, this is 35 degrees, or you might be thinking that this is from here to here. So that's 55 degrees. Which one's your reference angle? Why is it not 55? They're both positive, right? Which one? Why does it have to be 35? To the x-axis, right? Okay, so this is the distance to the x-axis. Okay, so this is going to be your reference angle. Okay, so when you are doing B, again, I would be thinking, all right, this is negative 90. So how many degrees past negative 90 is negative 105? Okay, so 15 degrees, so not a ton past that. So if this is my angle, okay, you want the shortest distance to the x-axis. The shortest distance is here to here. We were thinking about how this was 15, but that's not the reference angle because that goes to the y, not the x. Okay, so then what would this angle be? 75, so that's going to be your reference angle. And notice it's positive 75, not negative. The reference angle is always positive. Alright, and then the last one is 50 degrees. Theta equals 50. So go ahead and draw that in. Okay, so 50 degrees, it's less than 90. It is in quadrant 1. We know halfway is 45. Okay, so we're going to just make that slightly bigger than 45. Okay, so if this is our theta, we are trying to find the shortest distance to the x-axis. What is our reference angle?
X-axis of
The one that's the shortest distance. So if we went to the left side, see how that would be bigger than 90? Because you'd be crossing over the quadrant. So the shortest distance is what? 50 degrees. Right? So in this case, your reference angle is the same as theta. That's always going to happen when your angle is where? In quadrant 1. It's in quadrant 1. It's less than 90. Okay, that's what will happen. Alright, so yes. Yeah, so there it can be acute or it can be right. So there are some cases where it will be a right angle. I'm going to put